Hello everyone, welcome to MathsBridge. I hope you are all doing great. Thanks for joining. We shall continue our learning journey in C programming skills. Let's get started. Folks, please do visit us at our YouTube channel MathsBridge. I think you are already subscribed to the channel. If you have not, please do subscribe the channel and then support us. Thank you and then happy learning. Here is our today's agenda. C variables. It is nothing but a container where you are actually storing the data is nothing but a C variables. So how do you define it? A variable is a container to store the data value. That is how you can define. You can also say variables must be declared for a special type of data. So data means some whole number, some decimal number, characters, things like that, right? So we have a very variant of data, and hence we need to define a type also, what type of data that we are going to store. That is what we are reiterating here. Okay, so variables must be given unique name. What that means, like an identifier. So you have to identify by giving a variable name. Once you given a name to the variable, you cannot give same name to the other variable. That's what I mean by unique, right? So every variable has a certain rules in C standard definition. So one way I say that, like the variable starts with letters, for instance. Okay, there is the few more uh, checks that you have to perform while naming. What do you mean by like naming conventions that we use for declaring the variable in C. Variables are declared before using in source code. You have to declare first, then use it. Otherwise compiler throws an error. That's what we were saying. If you could recall, in computer architecture, there is a input, output, central processing unit, and memory. And then if you can look at at a high level how you are actually segregating memory, this is how one type of understanding example, a very generic architecture basically. So when you say address, means like you are referring a memory location by giving some address. So basically this is hexadecimal value which refer the memory location. Okay, for instance, but it's very hard us to understand and remember the numbers, right? Instead you are giving some kind of a logical name to it. That's what variable means. What we precisely saying, variable names are just a symbolic representation of a memory location. If you look at a syntax, type variable name equal to value. You assign the value to that variable and then end with a semicolon, because every executable statement should end with a semicolon in C. Okay, that is how. So we have, for instance, integer, float, char, double are the data types, right? These are also called as a keywords, right? You are not going to use for different meaning, because this is precisely to declare the data types. Okay, that is the syntax means. Like integer means what? Integer is used to store the whole number, meaning without fractional or exponential part. Okay, for instance, 525 or minus 125, these are kind of a whole numbers of type int is what we are referring. For instance, if you declare and then assign the value, integer value, this is how we say type is a int. This is called a unique variable name equal the value that you are supposed to be assigned. That is how you declare. Similarly, you can do the rest. Float means storing the real value is kind of float value, right? Means whole number dot decimal value is what we are referring float. Char means stores a single character, enclosed by, surrounded by a single quotes. This is how you see. So single character can also be stored using a variable. We have a double, which is basically a kind of a float, but storing a large floating values. Clear? So integer, float, char, double, most frequently we use as a data types in C. But the variants could be like unsigned, signed, short, long. These things that you can define as a specifiers, extensions to basic data types. For instance, you have the program like this, and then you can just look at all the executable statements within the main program. At a line number 8, if you see, I have a variable called my number, my num of type int. This is what we can call it as a declaration. We have to declare before we use in the program. That's what I was referring in previous slide. Int num. Now my num means, which is a data container, is going to use to store the integer values. Okay, let me assign the value to my variable. So my num equal to 100. That means I am storing the value 100. Okay, printf. If you try to print what was my assigned value for this variable, then I should get 100. This is what my 100 means. So if you can compile and then run it, I should get the output something like this. Here you look at, in this case what we are doing is we are declaring a variable and also assigned. So assignment was taken place during the declaration. So you can also do this. In a single line you can declare the variable and you can assign the value. So previously what we did, we declared first and then assigned. Now we are combining two statements into one. That's what we're doing. This also produces the same output. If you can compile and run it, what you get is like same value. Let's try out this one. Create a variable named my num1 and assign the value 150 to it. It's like an integer value. So how do you declare? Yes, you have to declare like this. My type is like int because I am going to store the integer value. My variable name is like my num1, right? And then assignment, so should be equal, right? And then value is 150, and then this whole statement should be ended with semicolon. This is how you have to do. Clear? Very good. One more additional tip. Now if you look at this program, what we are trying to do, we are trying to find out an address for this variable and then value in it. Okay, this is how we representing. So in this case, ampersand variable name, when I say this means like you are referencing the, what you can call it as a address. Okay, memory location number is what we are trying to look at here, right? If you see, this is a memory location, and then we are giving a symbolic name to it, is called my num. Because you declared as int, it is actually storing the integer value. Are you clear? Because it's very difficult for us to actually remember these addresses, and then these addresses can be vary from compile to compiler and then machine to machine. The minute that you run, what memory location that is going to pick. However, if you can refer this name, you always you can remember throughout your program, right? That is what it is. So giving a symbolic name, a logical name, to your memory location, but this is an address of for this variable. And then the value that we are storing in this program is like 100 in my num variable. That is what it means. If you can compile the code and see what is an output, this is how it goes. So the first line is basically a print address. This is what it is. And then second line means like a line number 11. Basically, we are trying to print the value, what it stores. It's like 100 at this instant. Let's look at this example. So we are trying to modify the value that you assigned previously. That's the case. So what you are saying is that you are declaring a variable of type int and assign the value during the declaration by itself. So that's what you are seeing in the line number 8. And then we are trying to print the address and then value. This is a step that we have seen previously. Now if at all you are trying to modify the value, instead of 100 you wanted to assign 150. How do you do that? Yes, this is a step that you can think. Okay, so these are basically like to readability point of view that I added printf statement, but not necessarily you need to add them. To distinguish between previous statements and current statement. How do you see the difference? Okay, now what you are doing is like simply you are assigning whatever the value that you would like to to the variable. That's called 150. Previously 100, now is 100. If you can print them, you will get it, right? So before modification, my value in my variable is 100, right? It's an address. So once you compile and run it, this is how the displays. So this top portion is basically here you are displaying, and this if you see 150 is what you get it, right? Before modification, after modification, but the address still remains same. That means you are referring same memory location. Clear? I hope this helps. Good luck, guys. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Happy learning. Thank you. Stay tuned to upcoming sessions.